Hello again. In this video, I'm going to continue working on the CodeFix provider that I have created in the previous video. So in the last video, we have created a CodeFix provider that allows you to change this code here to use the create method like here. And I ended the last video saying that there are edge cases that we need to handle. Before I write the next test, I want to refactor this test first to reuse part of this test in the next test. I'm going to extract this code here into its own method. Okay, let me copy this test here. Okay, so in this second test, I'm not going to use the full name of the immutable array type. And because of that, we expect the changed code to also not use the full namespace of the immutable array type. Okay, let me rename this test here. Okay, let me run the test. Okay, and the test fails because we expected the changed code to not include the full name of the immutable array type, but in the actual changed code here, the full namespace is used. So let's update the CodeFix provider to make this test pass. So in this code here, we are getting the node that is associated with the diagnostic, right? And we expect this node to be an invocation expression like this one here, right? So what I'm going to do, I'm going to inspect the code here to see if the accessed expression is simply immutable array of something dot empty without any prefixing code here. Okay, let me do that. Okay, so here I'm getting the member access expression that accesses the add member, and here I'm getting the member access expression that accesses the empty member here, right? Okay, and here I want to check the type accessed in this empty member access expression. So here I'm checking to see if the expression of the empty member access expression is a generic name syntax. And let me explain why. In this case here, this is the empty member access expression, right? And the expression of that member access expression is this expression here, and the type of this expression is a simple member access expression, right? Not a generic name syntax. However, in this case here, this is the empty member access expression, and the expression of the empty member access expression is this one here, right? And this is a generic name syntax. Okay. So based on this condition, I can decide whether I want to use the full namespace or not. Okay. Okay, let me try to run the test now. Okay, great. The test passes. Okay, let's handle another edge case. Okay, let me rename the test. So in this test, the type of this array will be immutable array of long, right? Now if we simply change the code to this, the type of the array will be immutable array of int, and this is because this literal here, which is 1, has the type int in C#. So in this case, the CodeFix should be smart enough to create an immutable array of long like this. Okay, so let's run the test. And as expected, the test fails. And the actual value doesn't specify long as the type argument for the create method. Okay, so let's fix the CodeFix provider to make this test pass. So let's talk about this code here. So this is an invocation of the add method, and because the element type of this immutable array here is long, the type of the parameter of this add method will be long, right? So here we have a method expecting a value of type long, but we are passing a value of type int, right? And in C#, this works because there is an implicit cast defined between int and long. And this causes this integer here to be cast to a long before it's passed to the add method. And the way I'm going to fix the CodeFix provider is to check if there is an implicit cast here, right? Let me show you how. Okay, here I'm accessing the argument as an argument syntax, and then I'm going to use the semantic model to get the type of this argument. Okay. So the semantic model has a method called Git Type Info. You give this method an expression, and it gives you back what is called a type info. Let me show you what this type info gives me access to. Okay, so here I have a property called type, and this is the type of the expression. Another property that I can access is the converted type property, and in the documentation it says the type of the expression after it has undergone an implicit conversion. If the type did not undergo an implicit conversion, returns the same as type. So this means that if the type and the converted type are not equal, then the value I passed as an argument was converted to some other type, right? So here I'm using a class called symbol equality comparer to compare the type and the converted type, and if they are not equal, then I say that the argument type was converted. Okay. So here, if the argument type was converted, I want to change this create method access expression to change the access member from a simple identifier to a generic name syntax that contains the correct type as a type argument, like this, right? So the type argument that I'm going to add here is the converted type, right? Because the converted type is the actual type of the immutable array. But here I have the converted type as a type symbol, so I need to create a type syntax from this type symbol, and let me show you how. Okay, so here I'm using a class called syntax generator to help me generate a type syntax from a type symbol here, right? And I'm creating an instance of this syntax generator class using the getGenerator method. And the getGenerator method accepts a document, and it will use this document to determine the language it will use for generation. And this is true because the syntax generator class allows you to use the same methods to generate code for both C# and Visual Basic. Because this document has C# code, the syntax generator will generate type syntax for C#. Okay, so this type expression method, I give it a type symbol and it gives me back a type syntax. And I'm going to use this type syntax here to modify this member access expression to have the access member contain this type syntax here as a type argument. Okay, let me show you how. Okay, so here I'm using the syntax factory class to create a new member access expression. The expression of this member access expression is the same expression for the existing create method access expression, which is this one here, right? And then the accessed member, instead of a simple identifier, I'm creating a new generic name syntax here, right? So for the generic name syntax, I'm using create as the identifier, but then I'm creating a type argument list that contains a single type argument, which is the element type here, right? So let me run the test now. Okay, and the test passes. Great. Okay, let me run all tests to make sure I didn't break anything. Okay, great. So, to recap for this case here, we use the semantic model to detect if there is an implicit conversion going on here, and if there is, when we create the member access expression here, instead of using a simple identifier for the accessed member, we create a generic name syntax with the identifier create, but then with the type argument list containing the destination type of the conversion. Okay, let's see the CodeFix provider in action. Okay, so here we have the warning. I'm clicking the light bulb and then use ImmutableArray.create, and the CodeFix provider created the correct type of the immutable array. Okay, so the CodeFix provider is ready for now. I will see you in the next video. Thanks for watching.